Alright, gang, we're looking at the cube root functions today. We'll talk about key features of the cube root functions, and obviously we'll hit on transformations to our cube root functions like we talked about yesterday. So here we go. Function number 1, 2, cube root of x plus 4 minus 3. Now we know we have 3 transformations, 1, 2, and 3. Anything inside of my cube root is going to affect my x values. So this is affecting the x, or the x value of my inflection point. Okay, we went positive 4, so we went left 4 units. This 3 right here is going to affect my y value of my inflection point, so we went down 3 units. And we had a vertical stretch by 2, vertical stretch by a factor of 2. So there are 3 transformations there. So let's graph our inflection point. We went left 4 units. We went down 3. Bam, there it is. Alright, so let's start our t-chart at 4, 3. Now let's find some more points on the graph. So if I was to pick, let's say, positive 4, negative 4, negative 3, sorry. If I was to pick positive 4, 4 plus 4 is 8. The cube root of 8 is 2. So 2 times 2 is 4, minus 3 is 1. So we have a point at 4, positive 1. If I was to pick, let's say, negative 12, negative 12 plus 4 is going to give me a negative 8 here. So when I take the cube root of a negative 8, I'll get negative 2, which will give me a negative 4 when I multiply. And then minus 3 is going to be a negative 7. So at negative 12, we're at negative 7. Alright, so my graph of my cube root function looks like that. Now let's talk about our key features. Domain and range, or negative infinity to infinity, or all real numbers. Symmetry is neither. It's not symmetric about anything. Again, the way I tell is if I was to replace my x with my negative x, would I get my original function, or would I get the negative of my original function? My intercepts, all we're doing is we're plugging in 0 in place of x and y. So if I want to find my x-intercept, it would be 2 cube root of 0 plus 4 minus 3. So we've got the cube root of 4 minus 3 times 2, so y equals that. Right, we're going to add 3 to both sides. We're going to divide by 2 on both sides. So you've got 3 halves equals the cube root of 4. Now we need to 3 halves y. Oh, sorry, don't do that step. What am I doing? Sorry, what am I doing? Okay, here we go. So 2 times the cube root of 4 minus 3. So there is your answer. If we were to plug in 0 for x, my y value is 2 cube roots of 4 minus 3. So 0, 2 cube roots of 4 minus 3. And to find my y-intercept, we're going to plug in 0 for y. So 0 equals 2 cube roots of x plus 4 minus 3. We're going to solve for x. So now we're going to add 3. We get 3 halves equals the cube root of x plus 4. Now we need to cube both sides. So you've got 3 halves cubed, which is 27 over 8. And then we're going to subtract 4 to get x by itself. So I'm just going to say 27 over 8 minus 4. I know that's improper, but hey. And we know our function is increasing. And our end behavior as x approaches negative infinity, f of x approaches negative infinity. And as x approaches positive infinity, f of x also approaches positive infinity. Okay, so that's our normal end behavior. We have no reflection, so our normal end behavior is just like it says, negative infinity to infinity, negative infinity, infinity to infinity. All right, let's look at example number 2. Now, example number 2, we have 4 transformations, 1, 2, 3, and 4. Right? Again, anything inside of my cube root is going to affect the x values. Anything outside affects the y values. So we know right now we went right 5 units with my inflection point. We went up 2 units. We had a vertical compression by 1/3, and we reflected over the x-axis. Those are our 4 transformations. So let's look at our graph. Okay, we can start our t-chart at our inflection point. My inflection point's at +5, +2. Alright, so let's plug in +4. 4 minus 5 is -1. The cube root of -1 is -1. Multiply that by a -1/3, we get +1/3 here. And we add 2, so 1/3 plus 6/3. It's going to give me 7/3. So we get 2 1/3. So at 4, we're at 2 1/3. If we plug in 6, we get the same thing. Okay, we get 6 minus 1, which is a +1. We cube root that. Times it by a -1/3. Okay, so we get +1 here. Times -1/3 is going to give me a -1/3. Sorry. There is 2 1/3. Alright, so now we get +5/3. So your point is at 5, +5/3. It looks about like that. So your cube root function looks like this. Alright, so let's talk about our domain. Guess what? Still the same. Range, still the same. It's not symmetric about anything. We know it's a decreasing function because as the x values are increasing, my y values are decreasing. So my end behavior would look like this. As x approaches -infinity, f of x is going up. As x approaches +infinity, f of x is going down. Alright, now let's find our intercepts. We're going to plug in 0 right here. So I've got y equals -1/3 cube root of -5 plus 2. Okay, I'm just going to leave it like that. So we get our y value is going to be this. Our x value is 0. And vice versa. We're going to plug in 0. We're going to solve for x. First step moves a 2. Multiply by a +3. So we get 6 equals the cube root of x minus 5. We'll cube both sides to get rid of my cube root. So 6 cubed, 216. We're going to add 5 to both sides, and we get 221. Alright, let's look at number 3. Now, number 3, we can see that we have a negative x value right here. So we could rewrite this as f of x equals the cube root of -x plus 6, if you're used to seeing it written like that. Now, there's a problem here. We have a negative x, so we need to factor out that x. So I'm going to say that's the cube root of -x minus 6 plus 7. Alright, so let's talk about what changed, right? We have 1 transformation, 2 transformations, 3 transformations. So again, this is inside of my cube root. So if it's inside of my cube root, it's affecting my x value, so we're reflecting across the y-axis. This is going to be a right 6, shift right 6, and we're going to go shift up 7. So my new inflection point is going to be at 6 +7. Oh. That's right. Alright, so now let's plug in some points. Let's find our graph of our cube root function. So we can start our t-chart at 6, 7. Alright, if I plug in, let's say -2, -2, okay, is going to give me a +2. Which plus 6 is going to give me 8. Take the cube root of 8, I get 2. Plus 7 is 9. So at -2, we're at +9. Okay, if I plug in 10, no, let's not do that. If I plug in, what, 12? Let's plug in 12. No, 14. 14 minus 6 is 8. -8. Okay, we take the cube root of -8, we get -2. plus 7 is positive 5. So at 14, we're at 5. Alright, so I can say my graph looks like that. Domain, still negative infinity to infinity. Range, same thing. Not symmetric, doesn't go through the origin. My intercepts, okay, we'll solve for those later. It is a decreasing function. And my end behavior as x approaches negative infinity, f of x approaches positive infinity because we're going up. And as x approaches positive infinity, f of x approaches negative infinity because we're going down. Alright, so let's find our intercepts. If I was to plug in 0, we have y equals the cube root of 6 plus 7. So we have a point at 0, cube root of 6 plus 7. And if I was to plug in 0 for y, I would get 0 equals the cube root of x minus 6 plus 7. We'll take the cube, or sorry, we'll subtract 7 on both sides. So we get negative 7 equals the cube root of 6 minus x. We'll take 7 and we'll cube it. We get 343 equals 6 minus x. Subtract 6. And we get x equals negative 337. So at negative 337, 0. Sorry, let's go back. When I cube a negative 7, it's going to give me negative 343. No wonder. So I take 343 and I subtract 6. Okay, or I add 6, for lack of a better way to say it, and I get negative 349. So it's going to give me a positive 349. That makes more sense. Okay, there we go. Because you can see my graph is decreasing, so way over here at 349 would be my y value of 0. Okay, that makes sense. Alright, sorry about that. So my intercepts are right there. Okay, your graph looks like that. We had 3 transformations here. Let's look at number 4. Last one I'm going to do for you. I've got 4 transformations here. We got bam, 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 and bam. So my inflection point, we went right 1 unit. We went up 3. I don't know why this is so blurry. Sorry, guys. Okay, we went right 1 unit. We went up 3. We had a vertical stretch by 5, and we had a reflection across the x-axis. So those are our 4 transformations for this cube root function. Let's graph our inflection point. We went right 1 unit. We went up 3. That's where I'm going to start my t-chart at. Alright, so again, we went right 1 unit, we went up 3, so let's go ahead and go, if I plug in 0, it's going to give me a negative 1 right here. Cube root of negative 1 is still negative 1. We multiply it by a negative 5, we get positive 5. We add 3, we get 8, so I have a point at 0, 8. I can go ahead and list that as an intercept. If I plug in at 2, I get 2 minus 1, which is a positive 1. Take the cube root of that, we get positive 1. Multiply by negative 5, that's negative 5, and then add 3, that's a negative 2. So at positive 2, we're at negative 2. Graph looks like that. So my function, cube root function, looks like that. Right, so we had a vertical stretch by a factor of 5, so that should make sense to me, being that those 2 points are so far away. My domain, guess what? Still the same. Range is still the same. It's still not symmetric. It is decreasing. My end behavior as x approaches negative infinity, f of x approaches positive infinity, and vice versa as x approaches positive infinity, f of x approaches negative infinity. Now let's find our other intercepts. Let's plug in 0 for y. First step, we're going to subtract 3 on both sides, and we'll divide by 5, so we get positive 3/5 equals the cube root of x minus 1. We'll cube both sides. Okay, so we get 27 over 125 equals x minus 1. We'll add 1 to both sides. And so I'm just going to say it's 27 over 125 plus 1. Because I guess I can find a common denominator for you. 27, if I want to add these, we're going to add 1. So 27 over 125 plus 125 over 125. And we get 152 over 125, 0. Yeah. There is your transformation of cube root functions.